Hello and welcome to my video on quadrilaterals and other polygons. My name's Darren from Maths Guru. What do you mean you've never heard of me? Come on, mathsguru.com. Basically my little corner of the internet web where all of these videos, downloadable lesson notes, yes, the stuff I'm about to write on behind me, and so much more are there for you. Free to sign up, please do so. Before I get started, here's the needy bit. Can you possibly subscribe to my YouTube channel? That one little click from you basically means so much to me. Very, very few people actually watch videos of maths. The fact that that you found this is huge. And by clicking just lets me know that someone out there has watched the video. And that just keeps me going, really. There are days where I sit here and I look at the dog and I go, oh, can't do this anymore. I love creating videos, but if no one's watching it, yeah, it just gets a little bit lonely. But if you can click, and at the end of the day I get 3 extra subscribers, I go nuts. It's crazy, really, and a bit sad. But anyway, didn't say I was not a little bit needy. Right, learning objectives. What are we going to do? Well, I'm not going to read through all of that. If you want to, pause the video and have a look over. But it's just building on the videos we have done previously. And in fact, so far we have looked at all of this information. All right, so one of the most important videos is the one on parallel lines, the one that basically I've already done prior to this video, and that's where we've learned about corresponding angles, co-interior angles, alternate angles, and vertically opposite angles. Yes, huge for the rest of this particular course. We also know that there's a lot of language. So if you need to, copy this into your summary books or do what you need to do, but you also need to know about the different types of triangles: scalene, equilateral, and isosceles. But more importantly, you need to know what these little marks here are signifying, because that's really the trick to the question. Along with, as I say, parallel lines. If I have 2 parallel lines marked with arrows like that, and I do another line through it, then that's where we get the Fuzzox rules. And again, you're going to say Fuzzox, and I'm going to say, yeah, Fuzzox. That's the corresponding co-interior, alternate, and vertically opposite angles, which I will never call them that at all. Right, that was the recap. Let's get into the good stuff. Right, what is a polygon? It's a missing parrot. See what I did there? It's a terrible, terrible joke. I know, I do it all the time. I can't resist it, all right? I told you I was sad and needy. Right, so today we're going to look at polygons. And what is a polygon? Well, I looked it up in a dictionary, and it said they are closed, 2-dimensional shapes with straight lines. Okay, so closed, as in there's not an open. Random. 2-dimensional shapes, they're not 3-dimensional, and they have straight sides, so no curvy sides, all right? They don't need to be the same length, and that's one of the important things here, that polygons do not have to have the sides the same length. Regular polygons, we do, but polygons, the sides can be completely different shapes. So here we go, and there are types of polygons. There are convex and non-convex. So you're going to say, but which type is which? And I'm going to say here. And thank you very much to Cambridge for allowing me to use your examples. You guys rock. Thank you so very much. Right, so a convex polygon is one where all of the interior angles are less than 180 degrees. So this is an example of a convex quadrilateral. All right, so a quadrilateral because it's got 4 sides. Quad bike. I know that's sad, but again, the whole point of it is convex quadrilateral is a 4-sided shape. A non-convex polygon is one where at least one interior angle is greater than 180 degrees. So here we go. Here is a non-convex hexagon. Hexagon because it's got 1, 2, 3, 4, 5, 6 sides. And again, knowing all the names of the different polygons actually is really, really important. But hold on a moment. What is an interior angle? Well, interior, we met this in a previous video, it's the angle inside. So if we go back to my quadrilateral, which is 4-sided, and convex, it's convex because all of these angles here are less than 180 degrees. If we go back and look at the previous one, we notice that this angle here and that angle there are reflex, i.e. they're greater than 180 degrees, and that would make it non-convex. Language, put it in your summary book. Couple of examples, you should be fine for an exam. Now, finding the sum of the interior angles of any polygon basically builds on a video we've done previously about triangles. So if I look at a triangle, there is a triangle. What do the angles inside a triangle add up to? 180 degrees. It's one of those ones you've learned forever. Right, I'm actually going to now draw another polygon. It's a quadrilateral. If you say it's a rectangle, I'll cry. Nothing on that said rectangle because I've not put any angles in it. But what's the angles inside of there? All right, if I looked at all my interior angles and added them, what would it be? Now, you're going to say 360 degrees. Yes? I'm going to say, but why? Well, actually, if I split this into 2 triangles, I start in a corner and make sure I've connected to every other corner. So I've started here. There's already a connection there. I've created a connection to that other corner, and there's already a connection there. I've got triangles. How many triangles I've got? Well, I've got 2. That's 180 degrees. That's 180 degrees, which when I add them together, give me 360 degrees. Oh, well, what about a different shape? You know where this is going, don't you? 1, 2, 3, 4, 5. Again, it's not regular. It's not supposed to be. In fact, most of those lines aren't even straight, but I'm going to choose a corner, and I'm going to make sure there's a line connecting every other vertex. All right, so I need to do one there, one there. There's already one there. So here we go. So I'm going to go one there, one there. I've got 180 degrees there, 180 degrees there, 180 degrees there. Add those all together. What do we get? 540 degrees. Now, actually, I can keep going. I can take any number of polygons and turn them into triangles, and ka-ching, I can come up with the number of interior angles. So what I'm saying here is that the interior angles, 1, 2, 3, add up to 180. These interior angles, which are in the corners, add up to 360. These interior angles here add up to 540. So interior angles are basically the inside angles. But is there a formula we could make?